All right, so in this video, I'm going to go over example 13 on the notes on asymptotes. Couple things that are important to recognize about some of these trig functions, like y equals tangent. First and foremost is that none of the trig functions, whether it's sine, cosine, tangent, cotangent, secant, cosecant, none of the trig functions have horizontal asymptotes. Okay, so that's an important thing to recognize right off the bat. They oscillate over and over and over again, so they never actually approach a number as they go toward infinity. So that's an important thing to recognize, is that we should not be looking for horizontal asymptotes. However, that does leave me with the idea of the vertical asymptotes and where to find those. Now, again, let me kind of recap some of the stuff I've mentioned in the past. Sine and cosine do not have vertical asymptotes, but tangent and cotangent do. And the reason for that is because I can rewrite tangent, y equals tangent, as sine divided by cosine. So, since this is a fraction, I need to look for where the denominator, that cosine x, is equal to 0. So, what I need to do at this moment is to find where cosine x equals 0. So, first thing I'm going to do in order to just kind of help us along with that is I'm going to just make a quick sketch of what the graph of cosine x looks like, just to get my point across with this one, okay? So important thing to know is it starts at 0, 1, and it's going to go all the way down to -1, all right? So it starts up here, and it's going to come all the way down. Now, I'm going to write down my little x marks real fast. So we go pi over 2, pi, 3 pi over 2, and 2 pi. And, well, both sine and cosine look like waves. So, again, this one starts at the top and comes down. So here we're going to hit 0, then we're going to hit -1, and we're going to come back up. So cosine looks a little something like this. Okay, and that's important bits of information. Again, we're looking for where this function hits 0, where it is an x-intercept. And if you notice, I have two cases just by looking at the graph right here on 0 to 2 pi. So I've got x equals pi over 2, and I've got x equals 3 pi over 2. Now, again, these are very specific answers, so I'm going to write that these are specific solutions. Now, let me point out again, if I were, for instance, to ask you for the vertical asymptote on, let's say, 0, pi, if I were to ask you to tell me where that was, the answer that you would give me is just x equals pi over 2. It's a very specific answer. I'm just looking for one or even two answers. Now, there's one problem with that. And the problem with that is if I consider cosine in a much more general sense. Like, let me, for instance, just give you, again, a little bit bigger of an idea. Because things to think about is sine and cosine are waves. They continue, to repeat over and over and over again. So I would have pi over 2. I'll have pi. I'll have 3 pi over 2. I'll have 2 pi here. Then I'll keep going. We'll do 5 pi over 2. We'll even do, not 6 pi, but 3 pi. And I'll include some negatives over here. So we'll do negative pi over 2. We'll do negative pi. We'll do negative 3 pi over 2. We'll do negative 2 pi. What's going to happen is, again, it starts here at 0, 1, and it comes down. All right, and goes back up, comes back down. And the same thing happens on the other side, though. So what's happening is we have this repetition over and over and over again. This, I'm going to use the word pattern, because that's exactly what it is we're looking here for the pattern. Where does it continue to cross the x-axis? Where do I continue to get 0 as my y value? So one of the things to notice is that both sine and cosine are like this. They repeat every 2 pi. So that means, notice, it hits its, I'm going to use the word apex, it hits its peak at 0 and 2 pi and negative 2 pi, and it continues to repeat like that at 2 pi over and over and over again. So that's how I'm going to incorporate this. So if I wanted to, I'm going to use the word get a general solutions. I'm going to generalize and write an infinite number of solutions. What I can do is I can take those specific solutions at pi over 2 and 3 pi over 2 I can take those specific solutions and I can add in that period of 2 pi. So I'll write it as 2 pi times n. Now, the n can be any number we want it to be, like 0 or 1 or 2 or -3. We can make it any number we really want as long as it's, a natural number or an integer, excuse me, because it could be negative. And so that's how I'm going to write general solutions is if I wanted to write down all infinite possible vertical asymptotes, I couldn't sit down and do it unless I'd had a bit of a shortcut, a bit of a trick to it, okay? So hopefully this helps you better understand, again, the difference between specific solutions and general solutions, but more specifically with y equals tangent x, how to find those asymptotes. I will see you again in the next example, which is example 14.